In example number 9, we're asked to find the dimensions of a rectangular box of minimum cost if the manufacturing costs are 10 cents per square meter for the base, 5 cents per square meter on each of the sides, and then 10 cents per square meter on the top. So let me go ahead and draw out a picture of what that guy looks like. Okay, so we've got a box. Like that. Okay, something like that. Okay, now what we're going to do is we're going to take a look at the dimensions that are going to minimize the cost. And so here's what we have. We've got 3 areas that we're concerned with. The first area is the base. Okay, so the bottom of the box. I'm going to color that here in yellow. And so the yellow area is 10 cents per square meter, like that. Okay, now let's go ahead and do some computations here for this box. So we've got some value coming down here. Let's let this be oh, I don't know, let's call it L, like that. Now it says the volume of the box. There's a couple things we have to use here. First, we've got a length here, we've got a width here, just like that, and the height of the box has got to be 1 meter. So I'm just going to go ahead and put a 1 here. So we already know the height. We also know another piece of information. We know that the volume has to be a total of 2 cubic meters. Meaning that the volume is when I take the length times the width and multiply it by the height. So here our volumes can just be length times width. It's still going to be in cubic meters because this was a meter. There's in meters. Okay. So what we're going to do is come up with an equation for the total cost. So we know that this yellow piece down here has an area. So we'll say the area of the base. Well, that area is equal to the length times the width, like that. Okay. Now also in this this is just the area, which means that we have a cost function of the bottom. So the cost of the bottom as a function of L and W, okay, is just going to be equal to 10 cents times L times W, like that. So that's the cost. This right here is the cost of this yellow area that I just shaded in. Okay, then, oops, I want a different color. Then we need the sides. So let's go ahead and do those, I don't know, an orange. So this side right here, this side right here, of course the sides on the back. All of those sides, not the top, but just all of the sides. Well, what are those side areas? Okay, so let's go ahead and do that. So the area of the sides, well, there's only one base, but there's going to be 4 of these sides. So one side, okay, one side has a height of 1, and this has got a length of L. So this side right here is just L times 1, or L. Now I got another one on the back side that is that same value. And then I also have this area here now, but this area is bottom part. The bottom length is 1. The height is, is W. The height is 1, so this area is just W. And so is the other side, like this. And so that means we have a cost in terms of the sides to be equal to, now each of those is 5 cents per square meter. So it's going to be 5 times the square meters, which is 2L plus 2W, So we could also write this as 10L plus 10W. Now the top of the box, let's just go ahead and I'm going to redraw this guy out here. And so we said that, I believe we said this guy was L, we said this guy was W, we had this guy as 1, and so we want the top area. Well, the top area is the same as the bottom area. So it's just L times W. So the area of the top is equal to just L times W, which corresponds to a total cost of the top as a function of L and W, just like this guy was and just like that guy was. I didn't write it here, but you get the idea. That is 7 cents. So 7 times the area. So we have a total now. Our total cost is given by each of these cost functions added together. So it's going to be 10 LW plus 7 LW plus 10L plus 10W. And that is the cost as a function of L and W. But now we can't really play around with that unless we know the relationship between L and W, and we do because of this volume. We know that the volume is equal to 2, so L times W times 1 is equal to 2, so I can get rid of either L or W. I'm going to choose to get rid of W, so we're going to say W is equal to 2 divided by L. So the cost as a function now of just L is equal to 10 times L times 2 over L plus 7 times L times 2 over L plus 10L plus 10 times 2 over L, just like that. So this is going to be 20 right here, 14 right here, plus 10L plus 20 over L. So that'll be 34 plus 10L plus 20 over L. Now L is not 0, hopefully, because otherwise you don't have a box anymore. Okay, and so what I'm going to do here is I'm going to try to solve this guy here. So C of L is equal to, well, what we want to solve this is we want to know what are the critical values. So that gives me 10 plus, now I'm going to get, when I differentiate this guy, the negative will come up front. I still have a 20 over L squared, like that. Now, my L values can go from 0, and they really can't go to, well, I guess they could go to infinity, but we're trying to minimize cost, so it's not going to go out that far. We're not going to include 0, because otherwise that causes an issue with our cost function. Okay, it also causes an issue here with our volume, because if L was 0, then 0 times W would have to equal 2. So we need some volume, so we can't let it be equal to 0. And then of course we're going to go out to infinity. So this is the range. Okay, this is the range of L. Okay, so let's go ahead and take a look. When is this guy equal to 0? Okay, and so that's going to be 10 will be equal to 20 over L squared. So L squared should be equal to 2, which means that L should be equal to plus or minus the square root of 2, but I'm going to go ahead and I'm going to use the positive part of that. So what I want is this guy to be square root of 2, and that means then that this guy over here has to be square root of 2, because now square root of 2 times square root of 2, okay, times 1 will give me a minimum cost. Now what is the cost? Well, that's when you take square root of 2 and you plug it into this guy. They didn't, I don't believe, ask for that. I think they just asked for what were the dimensions. Okay, so that's how you go ahead and work that problem.